Welcome to our deep dive into automotive validation. Today, we are moving beyond the dashboard to show you how engineers turn raw test data into critical engineering decisions. This is automotive test reports explained in detail. Our journey today follows the validation pipeline. We'll start with the physical vehicle, move through ECU testing and execution, and end with the final report that decides if a car is ready for the road. To test effectively, we have to isolate the core logic. Think of a car's ABS system. We don't need the whole car in the lab. We focus on the ABS ECU. This is our system under test. We monitor its firmware, sensor inputs, and communication interfaces. This is where code meets hardware. On a test bench, use scripts to simulate real driving. For example, we tell the ECU the car is going 100 kmph and then trigger the brakes. We watch how the hardware reacts to our digital commands. Imagine you start a test. It fails instantly. Look at this signal trace here. The voltage drops to zero immediately. It is a software bug. Or did a wire just come loose in the lab? Let's find out, okay? Every test ends in one of three ways. Pass means the car did exactly what we expected. Fail means it did not. But then there's blocked, right? So that's when we cannot even run the test because something else is broken. When a test fails, we don't guess. We look at the evidence. We analyze the error codes and telemetry logs. For example, an unexpected value error combined with a noisy signal trace tells a very specific story about what went wrong. Look at this orange spike in brake pressure here. It's way above the physical limit of 250 bar. Since the hardware cannot actually do that, we know we are looking at data error, not a physical explosion. The biggest job for a test engineer is deciding, is it a ECU defect or an ECU test environment issue. A defect is a software bug or logic error. An environment issue is a broken cable in the lab, a slow simulator, or a bad test script that has been written. Knowing the difference saves, weeks of wasted time in the testing. To fix a bug, developers need a clear map. We provide reproduction steps, show the expected versus actual behavior that we are observing, and uh, and attach the telemetry evidence. You can call it as logs. Precision here is the key to fast fix, like the defect fix they have to give. Why would OTA, over the air update test, be blocked here? In this case, the issue is fine here, but the cloud server is unreachable. If the road is closed, you can't test the car. Validation is a cycle. We find a fault in firmware version 1.0, the developer fixes it, and we come to retest. Look at the difference here. Version 1.0 is full of signal noise that you could see, while version 1.1 shows a perfect, clean sine wave. At the end of the project, we look at the data aggregate. If we have 90% of no or 92% of tests passing and 98% system coverage, and our defect count is actually dropping, trend is dropping, we can finally hit that approved button for the release candidate. Being a great validation engineer means three things will come: investigate the evidence, isolate the cause, and document with precision. You are the final gatekeeper for a vehicle safety. A test result is more than just a pass or fail. It's about understanding the evidence, separating bugs from setup issues, and providing the data needed to build a safer vehicle. In our next video, we are talking things to the next level. We'll be looking at how we validate ADAS, advanced driver assistance systems, teaching cars how to see and react to the world around them. Hit subscribe so you don't miss it.